this is Mr. Eshelman. We are going to make a video where I walk through how to do the solutions to the practice final exam for our Algebra I credit recovery class. So this is the exam on your screen. This is the first page. I'm just going to walk through all of the questions and solve this so that you can play this video at home or in class and work through the problems on your test as I work through them. Pause it, go back if you need to, so that you can understand how to do these in preparation for your actual final. So just getting right into it, we're going to look at number 1. It says, which number produces a rational number when added to 0.53? So this is going way back to the start of when we started looking at rational and irrational numbers. And what you need, a couple things you need to remember to do this, are to know whether this is a rational or an irrational number. And a rational number, remember, is something that can be written like a ratio of two integers. So it can be written like a fraction of 1 divided by 2, or 15 divided by 43/700, something, anything like that. But so this can be written like that. It can, and because you can write it like 53 over 100. Okay, so this is a rational number. And you need to know that when you add a rational number with another rational number, you get a rational number. Okay, so which of these, A, B, C, or D, are rational numbers? Well, A is a rational number. Okay, so A can be written like a ratio, so it's rational. And if you're adding it to another rational number, you get rational. So that's 1. This B is irrational. Pi is something that goes on forever, infinitely. Without a repeating pattern. Square root of 5 is something that goes on forever with a non-repeating pattern. And this decimal value goes on forever with a non-repeating pattern. So these are all irrational, which means they are not solutions. Okay, let's look at number 2. Number 2 says to simplify this expression. It's a basic expression with one variable. So really the first thing you need to do here is distribute this 4 to the expression inside the parentheses. So to do that, we multiply it by both the x and the negative 3. And we get 4x minus 4 times 3 is 12. Now, these other terms are still here, minus 2x plus 9, and now you just need to combine like terms. So 4x and negative 2x are like terms. When you combine those, you get 2x. Negative 12 and positive 9 are like terms. When you combine those, you get negative 3. So it's a simple two-step process to get your answer. Now this one is not saying simplify, it's saying solve. We have an equal sign, so there's something to solve. We have one variable, so it means solve for that variable, which is x. So this is just using the straightforward properties of algebra, where if we have two sides of an equation are equal, we can do the same thing to both sides and still have equality, okay? So we strategically choose to do it in a way where we get x isolated. So we're going to start with this. This is where we're starting. The first thing we're going to do is subtract 4 from both sides of this equation. Okay, so if we do that on this side, we're just left with negative x. And if we subtract 4 from this side, we get negative 8 minus 4, okay, which is negative 12. So we're left with negative x equals negative 12. Now, we have negative x. We want positive x. So let's multiply both sides by negative 1. That's going to give us x equals positive 12. Okay? Now, what I've seen in some of these practice tests that got turned in, a lot of people kind of start out the right way, but then they just get sloppy. So I want people to show their work, show their steps on the test. Okay? And if you're writing your tests out, or your steps out really cleanly, you're less likely to make silly mistakes, right? I see a lot of people with very small handwriting. They have a negative x here, and then all of a sudden the negative goes away because they didn't see it, or they just got sloppy. So when you write your steps out in your solution very cleanly, it's much harder to make those mistakes. And if you write them out cleanly, I see where you were going. So even if you make a silly mistake somewhere along the way, I can give you partial credit for that. Moving on, we've got number 4. Number 4 is a word problem. It says Mateo had $98, which is 7 times as much money as Kindle had. How much money did Kindle have? Okay, so to set this, and it says select the correct solution method below where X represents Kindle's money. Okay, so this is kind of 2 parts. It wants to see how you set up the equation and then solve it. Well, if Mateo has $98, let's just write 98, and that is 7 times how much Kindle had. So if we say X is how much Kindle has, that's X. 98 is 7 times as much as Kindle has. So 7 times what Kindle has is 98. So this is how you set it up. And then as we just went through, to solve this, to isolate X, you divide both sides by 7. So 98 divided by 7 equals X. If you want to use a calculator and find 98 divided by 7, that's 14. So X equals 14. Okay? So which of those choices is correct here? 7x equals 98. That's what I have. 98 equals 7x. Same thing, just flipped. 7x equals 98. Divide both by 7, and Kindle has $14. Number 5 says to solve. Okay, so we have a variable x on both sides of our equation. We have something we need to distribute here because we have parentheses around an expression. Okay, so we just need to follow those steps. So first I'm going to distribute the 3 on my left side, and I'm going to get to 12 minus 6x on my left side, and I'm just going to leave my right side alone. I haven't changed anything. I've just used the distributive property. Now what I want is all my terms with an x on one side of my equation and all my terms without an x, my constants, on the other side. So I can move it either direction. I'm going to move the negative 6x to this side by adding 6x to both sides. When I do that, if I add 6x to this side, I'm left with just 12. When I add 6x to this side, negative x plus 6x is 5x, and I still have the plus 1. Now I'm going to subtract the 1 from both sides, and I'll be left with 11 because I subtracted 1 on this side equals 5x. Now I want x to be isolated, so I'll divide both sides by 5. So 11 divided by 5 equals 5x divided by 5 is just x. So x equals 11 over 5 is the answer. That's C. Just in case that didn't get in the video, I want to make sure you see it. Number 6 is another word problem. Matt charges $9 per hour to babysit. He babysit last Friday night for 5 hours. Then he babysat again on Saturday. He earned a total of $99. For how many hours did Matt babysit on Saturday? So this is going to be something we set up with an equation and then solve for the variable we have. The variable we have is going to be how many hours did Matt babysit? So we're looking for hours on Saturday. So on Friday night, what we know is he earned a total of $99, okay? So 99 equals something. We also know that he babysat for 5 hours on Friday night and earned $9 an hour. So we can take $9 an hour times 5, and that's how much he earned on Friday night. And then on Saturday night, he babysat again, and he earned $9 an hour again, but what we don't know is how many hours he babysat. Okay, so we're starting here. Now, what I'm looking at as far as my answers, it's looking for 2 answers. It's looking for one for the equation that models the situation and one that solves for x. Okay, so using the distributive property here, or if I had set up the equation a different way, I would have seen that if he's earning $9 an hour and he worked 5 hours on Friday, and then he worked X hours on Saturday, then 9 times, this is the total number of hours he worked, would have equaled 99. So this matches this, and this is one of my answers. This is the equation you set up. And then to solve that, you use your distributive property. You then undo this setup so that you're solving for x by subtracting 45 from both sides. 99 minus 45 is 54. Then divide by 9 on both sides. X equals 6. So on Saturday, Matt worked for 6 hours, and he earned $99 total. Okay, number 7. Number 7 solves this equation. 3 minus x over 2, I'm just going to rewrite it here, is greater than or equal to 12. So we've got a couple things going on here. Okay, we've got an inequality. So I shouldn't really say an equation, I should say it's an inequality. Okay, and I want to get x isolated. I want to solve this for x. So I can do the same thing to both sides. I can subtract 3 from both sides, so I'll do that. If I subtract 3 from the left side, the 3 goes away. And I'm left with 12 minus 3 over here. 12 minus 3 is 9. Okay, now I can multiply by 2 on both sides. If I do that, I'm left with just negative x on the left side. I'm still greater than or equal to, and I multiply 9 by 2 and get 18. Now here's the one little tricky part of this. You have to remember, or you have to think about really hard if you don't remember. We need to remove the negative from this x. We're going to do that by multiplying by negative 1. Okay? But if you multiply or divide by a negative number on both sides of an inequality, you have to flip the inequality. Greater than becomes less than. Less than would become greater than. So if I multiply by negative 1, I will get x here, and I will get negative 18 here, but I have to flip this sign. Okay, so greater than or equal to becomes less than or equal to, and that becomes your answer. All right, another way to approach this on a multiple choice test, is if you suspect this is the right answer, you can try with your calculator numbers for x on both sides, right? You can try negative 19 and plug it into the original equation, 3 minus negative 19 over 2. And is that going to be greater than 12? Yeah, it is, okay? So x is, it's holding true so far, okay? So a value where x is less than negative 18 holds true for this equation, okay? So you can just use tricks like that to verify that maybe you've got the correct answer. You can try it for negative 17. If this is correct, then negative 17, it will not be a true expression. Is this going to be greater than or equal to 12? No, it shouldn't be if we've solved this correctly. No, it's not, okay? So these are things you can do on a multiple choice test to verify you've got the right answer. All right, this next number 8, solve for x, okay, where kx minus 3 equals 5. All right, the only way this is different is that this isn't an actual number, it's just k, but you need to assume it's a constant. It's saying solve for x. It's not saying solve for k, it's saying solve for x. So let's just go through the steps. K is something that gets multiplied by x. So eventually we'll get to a place where we divide by k. But first, we're going to add 3 to both sides. So in doing that, we get kx equals 5 plus 3 is 8. Okay, now we're going to divide both sides by k. X, if we divide this by k, we're left with just x. Divide this by k, that's what we have. That's D. Simple as that. Okay, on to number 9. Number 9, this is a really easy one. It says a gas pump measures the volume of gas to the nearest 1/10 of a gallon, 0.1. Which measurement shows an appropriate level of precision? Okay, so the whole key here is if this has one place beyond the decimal, okay, so we have a decimal, then we have one value after the decimal point. It's just 0.1. It's not to the nearest 0.01, it's to the nearest 0.1. So we have one place after the decimal. This is the measurement of your choices that only has one place past the decimal. Okay, decimal, then one value. So that's it. Number 10, a plane ride lasted 6.4 hours. how many seconds did the plane ride last? Okay, this is just unit conversion. So we're going to be doing a series of multiplications by what really are 1. Okay, I'm going to start with 6.4 hours, but I want to get that in seconds. Okay, so I'm going to multiply 6.4 by 1, but it's a kind of a tricky one. This is one where 60 minutes equals 1 hour, okay? 60 minutes equals 1 hour. So I can multiply by 60 minutes and divide by 1 hour, and I haven't really changed the value, I've just changed the units. So 6.4 times 60 is going to convert hours into minutes. And then that value in minutes, I'm going to convert by saying there are 60 seconds in 1 minute. And what you see is that if you multiply 6.4 hours times 60 divided by 1, I cancel my hours. And then I multiply by 60 seconds in 1 minute, I cancel minutes. And I'm left with 6.4 times 60 times 60 seconds, which if you put into your calculator is 23,040 seconds, which is A. Okay. Number 11, f of x. This is functional notation, okay? This is not, when we're looking at this is not f times x. This is a function, and you say it f of x. The function is f, the variable is x, okay? When it's 8 times x minus 7. What is f of 4? All this means is where you have an x here, plug in 4, right? This says f of x, this says f of 4. So let's plug in 4. Instead of 8x minus 7, we'll have 8 times 4 minus 7. We just plugged in 4 where x was. Put that into your calculator if you need to. You'll get 32 minus 7, which is 25. That's your answer. Very easy. Okay, don't make it too difficult. Whenever you have f of a number, just whatever the variable is for the function, plug that number in for the variable, put it in your calculator if you can't do it by hand. Okay, well, we're talking about functions. This asks, does this graph show a function? Explain how you know, okay? So the thing about functions when they're plotted on a graph, they cannot have, if you've got x, which is always the input to a function when we draw it on a graph, the horizontal axis, the x-axis, is always the input. If you have an input, say x equals 3, just as an example, then that's got to give you just one output. But here you see on this graph, x equals 3 has 2 places where it's got y values, okay? So I'm drawing a vertical line, and I'm finding that vertical line crosses 2 points on my graph, okay? I could draw other vertical lines that cross that too, but in any case, if you've got one, at least one, or many, but at least one vertical line you can draw on a graph and it touches more than 1 point, this is not a function. Okay? So, this is not a function. No has got to be the answer. It's one of these two, and it's because it fails the vertical line test. Now, I did notice on some of these that I looked at, your practice tests, some of you did put this, okay? Why is this wrong? This says, no, it's not a function, which is correct, but the explanation it gives, there are y values that have more than one x value. Now, this is tricky, okay? Because you actually can have a y value, okay? If the function looked like this, okay, what this is saying is there would be a y value, say y equals 5, say this is 5, that had multiple x values. Maybe this is y equals 5 when x equals negative 4 and when x equals positive 4, okay? That's what this is saying. There are y values that have more than one x value, but that's okay. It's only the opposite that can't be true, okay? You can't have x values that have more than one y value, okay? That's the case here, okay? So, but really all you need to remember for the purposes of what we're testing you on in these graphs, if you can draw a vertical line and it touches more than 1 point on your graph, then it's not a function. Okay, the domain. Domain is the set Domain, what you need to remember is the domain is the set of all inputs, or when you're on a graph, okay, the inputs are the x values. So all possible x values in the function, okay? So where are my x values in this function? They're between here and here. So they're in this range, okay? And this is x equals -4. And this is x equals 2, okay? Because it's a closed dot here, and this doesn't wind up in the choices, doesn't become an issue, it's a less than or equal to or greater than or equal to situation, okay? If it were open dots, then you wouldn't be including these points, and you would just be straight, the values would be greater than -4 and less than -2. But that's a subtlety you don't need to worry about with the choices you have here. You just need to know that your values are between -4 and 2. So the domain is x, all values of x between -4 and 2. Okay, that was 13. Let's look at 14. Over what interval is the function in this graph decreasing? Okay, decreasing just means as we increase x, meaning we go this way, that y, the value on the horizontal axis, is going down, okay? And there is a specific interval in this graph where that's happening. It starts to decrease right here. It stops decreasing right here. So this is x equals -3. This is x equals 2, okay? So it is decreasing between -3 and 2. Is that one of the choices? Yes. -3 is less than x. Okay, so somewhere where x is bigger than -3, but it's not bigger. I'm sorry, x is greater than -3, but it's not greater than 2, because when you get to 2, it stops. Okay, so between -3 and 2, that's where this is decreasing. X is between -3 and 2. Now, I noticed a lot of people, I think it's just a matter of not understanding this notation in number 15. Number 15 says f of x, that's a function, f of x equals 5x minus 6, g of x equals x squared minus 4x minus 8. What is f plus g of x? Okay, so this notation just tells you add these two functions together. Okay, f plus g, add f to g. F is 5x plus 6. That's f. Add that to g, which is x squared minus 4x minus 8. Okay, that's not magic. I just copied these and I put a plus there because it said to do a plus. Now, when I've got addition, okay, I don't even need these parentheses. Okay, I can just remove those. And now I combine like terms. So I'm going to do that one at a time here. I've got one term that has an x squared, so we've got to keep x squared. I have two terms that are of order 1. They just have an x, so 5x and -4x. When I add those together, I get -1x, which is just -x. And when I add 6 and -8, I get -2. So f plus g of x is x squared minus x minus 2. Now, this is supposed to say if, okay? If f of x is 5x squared minus 3 and g of x is x squared minus 4x minus 8, find f minus g of x. So same difference, only we're doing subtraction instead of addition, so let's set it up. And I'm going to keep the parentheses around these because they do become important when you're subtracting. I've just copied f of x and g of x, and I've subtracted g of x from f of x. That's what this is telling me to do. Now, when I'm subtracting all of this, the negative sign here is going to carry through to each of these terms. So when I remove these parentheses, I'm going to be careful that I make sure all of the terms here have their sign switched. Okay? If they're positive, they become negative. If they're negative, they become positive. So we'll have 5x squared minus 3. Now, I've got to be careful. Minus x squared, okay? Positive flips to negative. Negative 4x flips to positive 4x. Negative 8 flips to positive 8, okay? Because I have to subtract every one of these terms, okay? And if I subtract it, it becomes the opposite sign. Now it's combined like terms. I have two terms with x squared. 5x squared minus x squared becomes 4x squared. I just have one term with an x. And I have two constants, positive 8 and negative 3. 4x squared plus 4x plus 5. That's A. Okay? Again, just to reiterate while you're watching this, if you've gone this far, always show your work. If you make a little mistake in here, I can give you partial credit. Try not to make little mistakes, but if you're showing your work, you're less likely to make them, and you get partial credit if you do make one. All right, this graph, number 17, this graph shows the distance that a robot walks. What's the robot's speed? Okay, you have to know here, I guess, and you could ask me if you're taking this test and you don't know, but speed means distance, amount of distance that's covered per unit of time. Okay? So really what this is asking you to do is calculate the slope. How much distance does it cover in a certain amount of time? You could pick any point on this graph, okay, because it's a line. So a line has a constant slope. I'm just going to pick the point here. After 1 minute, it's gone 10 feet, okay? So if I calculate the slope using these 2 points, and this is maybe going too far, I can look at this and just know it goes 10 feet in 1 minute, so its speed is 10 feet per minute, okay? It's really that simple. If you hadn't quite seen it that way, you could have picked 2 points on here, any two. You could pick the point 0, 0, and the point, just for instance, 2, 20, and calculated the slope as y2 minus y1 over x2 minus x1, which with these 2 points would be 20 minus 0 over 2 minus 0, which is 20 over 2, which is 10, okay? And you still could have got there, okay? So this really what this is asking, calculate the slope, all right? And remember this formula for the slope, which if you're taking this class in the classroom, we do have a chart on the wall that shows you how to calculate slope if you don't remember. Slope-intercept equation of the line. Again, we have a chart. If you forget this when you're taking the test, you can reference, but slope-intercept equation for a line is y equals mx plus b, where m is a slope that you calculate, and b is a y-intercept that you're going to calculate, or see on a graph, right? So first, we're going to have an equation in this form. Let's calculate the slope as, if this is the point x1, y1, and this is the point x2, y2, and we calculate the slope with this formula. Let's just plug them in, okay? Negative 4 is x2, or y2, excuse me. Negative 4 is y2, y1 is 8, x2 is 6, y2 is 0, or x1, I'm sorry, is 0. So just put this in your calculator. Here's another place I see people making simple mistakes because they're going too fast. If you can't do this quickly in your head, get your calculator. Put minus negative 4. Negative 4 minus 8, that's negative 12. Put 6 minus 0, which hopefully you don't need a calculator for, is 6. And then do negative 12 divided by 6 is negative 2. So your slope is negative 2. And right here on the graph, it shows you the intercept is where it crosses the y-axis. That's at the point where y equals 8. So y-intercept is 8. Okay? So if we put these into this form, we get y equals negative 2x plus 8. That's it. Now, this is multiple choice, so it was in this form. Now, they could have gotten a little tricky, and they could have had a choice be y equals 8 minus 2x. That would be the same thing, okay? So if that was a choice, that would have been correct. But they had 2x first, the negative 2x first, and then the 8 second, so be aware, you can switch the order. Let's move on, number 19. 19 is another word problem. It says customers can pick their own berries at the gooseberry farm. They pay $3 to enter the farm and $2.50 per pound for the berries they pick. Write an equation to model the total cost, y, for X pounds of berries. Okay? So how much you pay total is we're going to let that represent y. And we know that just to walk in the door, you're going to pay a flat fee of $3. Okay? It doesn't matter how many berries you pick, you're paying $3. But you're going to pay for every pound of berry you pick, X, $2.50. That's 2.5 times the number of pounds of berries you pick. So this is the equation, y equals 3 plus 2.5x. Okay? Now, like I was just saying, they have a solution here that fits. We just have to flip the order that they wrote them in. Okay? So it's the same thing as writing 2.5x plus 3. Okay. Number 20, use the coordinates of the labeled point to find the point-slope equation of the line. Okay, so we need point-slope is a little bit different. Again, there's a chart on the wall that's labeled point-slope equation of the line, and it's got a formula that looks like this. Y minus y1, that's a specific point, equals m times x minus x1. That's the point-slope equation for the line. This is a slope, and you're picking any point on the line, which is the point x1, y1. So I can use this point. That's a point on the line. So I'll let my x1 be equal to 2 and my y1 equal to -1. So we've got x1, y1. All we need to do is to calculate the slope. Okay, how are we going to calculate the slope? Well, let's look at another point we can tell on the line is 0, 3. Okay, so let's calculate the slope with these 2 points. I'm going to let this be 0.2 and this be 0.1. My formula for slope is going to be, tell me to take the difference between the y values, 3 minus -1 divided by 0 minus 2, which is, and you use your calculator again if you can't do this easily, 4 divided by -2, which is -2. So this is my slope. This is my x1 and y1. Now let's just put these into this form. Y minus -1 equals -2 times x minus 2. Now y minus -1 is really y plus 1. So this is my point-slope equation for this line, and that is right here. Choice B. '21. A bean plant grows at a constant rate for a month. After 10 days, the plant is 35 centimeters tall. After 20 days, the plant is 55 centimeters tall. What equation models the height of the plant y after x days? Okay, so this is telling you 2 points on the line. Okay, if we let x be the number of days and y be the height of the plant, then we have 2 points on our line. We have 10, 35, and we have 20, 55. Okay, so if you were to graph that, just roughly here, and we've got 10 and 20, and we have, say, 10, 20, 30, 40, 50, 60. Okay, we'd have a line that looked like, and you don't have to do all of this, I'm just doing it to kind of show myself what it looks like, so I can gain a little more confidence. We'd have the height of the plant looking something like this. Okay, where this is number of days, this is height. The x-axis, the x variable is representing number of days, the y variable is representing the height of the plant. Okay, with 2 points we can figure out the slope. The slope will be slope m equals 55 minus 35 divided by 20 minus 10, which is 20 divided by 10, which is 2. So you know the slope of this function is 2. That eliminates this choice. That's not an equation with a slope of 2. Okay? Now, it looks like these other choices are in point-slope form. Okay? So maybe one of these is actually in the form that's using one of these points. And if you look closely enough, you'll see that it's actually C. C is using the, no, I'm sorry, it's not C. It's actually B. B is using the point x equals 10 and y equals 35 with a slope of 2. So that's my answer. Okay? This is using the point-slope equation of a line that you can derive, you can calculate it because you have 2 points on that line. Which of these, this is number 22, which of these is a point-slope equation of the line that is perpendicular to this line? Okay, this is a point-slope equation for a line. And it passes through this point. Okay, so you need to know something here. You need to know, and again, this is a chart on our wall, perpendicular lines have slopes that are negative reciprocals. So the slope of this line is 4, but we want a line that's perpendicular to that one. The negative reciprocal of 4 is negative 1 divided by 4, okay? The reciprocal of 4 is 1 over 4. The negative reciprocal would be negative 1 over 4, okay? So this is the slope of our new line. Now you can see you've already eliminated choice D and choice B. Those have slopes that aren't negative 1/4. A and D have slopes that are negative 1/4. Okay, but now it says it passes through this point. So if we were to write the point slope equation, we would say y minus y1, that's a point on our line, equals the slope x minus x1. So x minus negative 3 is really x plus 3, okay? So this is our point slope equation. This looks like it matches C. All right, we have y minus 7, and we have the x plus 3. So you need to get your signs right, okay? You need to be really careful when you're referencing that point slope equation to get your signs right. Okay, number 23. Which option shows the graph of 3y plus 18 is greater than or equal, is greater than 5x? So, if you were paying some attention, you can notice that it's greater than. It's not greater than or equal to. Okay, so when we're greater than, we're going to have a dashed line, okay? Values on the line, that's described by this expression, are not going to be solutions, so you'll have a dashed line. So B is out because it has a solid line. C is out because it has a solid line. So this is representing a region where the y values are less than what you would get on the line, and this is representing an equation where the y values are greater than what you would get on a line. Okay, so that's going to be the key to quickly figuring this out. Let's isolate y. So we're starting with 3y plus 18 is greater than 5x. If I move the 18 to the other side by subtracting it, I get 3y is greater than 5x minus 18. Okay, and then I can divide both sides by 3, and I get y is greater than 5. You can distribute it at the same time if you want. 5/3 x minus 18 divided by 3 is 6, okay? But these don't even really matter that much. What you need to realize is that you're coming up with an inequality where the y values are going to be higher than some line, greater than, okay? And D is the one where the y values are greater than a line. And I'm sorry if that didn't show in the video before. You were between choice A and choice D, and then you figured out that choice D is the one where the region is represented with y values greater than what turns out to be this line. '24 is possibly one of the easiest questions on the test. What is the solution to the system of equations graphed below? And you see they show you what the equations are, and you could figure it out by using those, but it tells you just look at the graph basically, right? So what's this point? The solution is where the two lines intersect, okay? That's where x and y are the same for both equations. So that point is x equals 6, y equals 9. We write that as an ordered pair like this, okay? X is 6, y is 9. That's D, okay? That one should really take you about 10 seconds. This one says use the substitution method to solve the system of equations. All right, so now on these questions on the test, I don't know what method you're using, okay? So even though it says use the substitution method, I mean, I guess if you show your work, you do, and but if you're showing any work and you're solving this system, however you solve it, that's okay with me. But really, the substitution method is the simplest here. The substitution method says, hey, use the information in this question. In this, we have two equations, 1 and 2. We're going to use the information we have in equation 2 and just plug that information into equation 1, okay? So we know y equals x minus 1. Let's substitute where it says y in this equation. Let's substitute x minus 1. So if we do that, we get 3x, okay? We aren't substituting for x, we're substituting for y. Plus 2 times, what do we know y equals? We know it equals x minus 1, equals 13. So this is just rewriting equation 1 where we're using the information we have in equation 2. Now we've got to solve this for x. So let's distribute. And let's combine like terms. Let's move this 2 over. Let's divide both sides by 5. So we know x equals 3, okay? So really you could, if you felt really confident, you could stop right here and know it's D. Or if you'd have kept going, let's plug in x equals 3 into one of our equations. So if we plug in x equals 3, y equals 3 minus 1, y equals 2, okay? So that gives me extra confidence I've done it right, because there's the solution, the only solution where x equals 3, I happen to also confirm that y equals 2. Number 26. This one says use the elimination method, okay? So the elimination method is we're going to either add or subtract the two equations to each other so that one of our variables cancels. And if you look at this, you'll see in this equation you have a positive 4y, in this equation you have a negative 4y. So if we just add these together, we're going to eliminate the y, and we're going to have something we can solve for x right away. So adding this equation to this equation, you get 2x plus 3x is 5x. Positive 4y plus negative 4y is 0, so I'm just going to leave that out, equals 10 plus 5, which is 15. You can look at this and solve it to get x equals 3, okay? Unlike the last one, we aren't quite so fortunate. We have two possibilities still, but we can eliminate this one and this one. So let's just go ahead and figure out y by plugging x equals 3 into one of these equations and solving it. I'll just use the first one. So 2 times x, which we know now is 3, plus 4y equals 10. This is 6. Let's subtract 6 from both sides. 4y equals 4. Y equals 1. So x is 3, y is 1. We write that like this. That's D. Number 27, use the elimination method to solve the system of equations. 4x plus 3y is 11, x minus y is 8. Now, this one isn't quite so simple, but what we can do to get to a place where we can eliminate something is multiply this entire equation, both the left and the right side, by 3. So we'll have this first equation still there. We'll have the second equation entirely multiplied by 3. Every term gets multiplied by 3. Now we can add the two equations, and we'll get a new equation where 7x equals, this cancels, 35. That can get both sides divided by 7. X is 5. Let's plug x equals 5 back into this. So 5 minus y equals 8. So negative y equals 8 minus 5 is 3. So positive y equals negative 3. So x equals 5, y equals negative 3. 5, negative 3 is C. Number 28. Which graph represents the solution set to the following system of linear inequalities? Y is greater than or equal to 2x plus 7. Y is greater than negative 1/3 x minus 2. So to do this quickly, you can recognize some things, right? This, whatever the line is here, it has a slope of 2. It's steeper. It's an increasing line. So it's going to look something like this. Okay? This line has a negative slope, and it's a fraction, so it's going to look something like this. Okay? That's what we have. So this one has the greater than symbol. Okay? So it's going to be a dashed line. So the one that looks like it's about going this direction is going to be dashed. Okay? That eliminates B. That eliminates D. Those are solid lines. We need a dashed line for that one. Okay? Now, the line that looks like this, it's going to be greater than or equal to. That's the case for both of these, okay? A and C are both our possibilities, okay? They've got the right solid and dashed combination. We need to figure out, are we in this area or are we in this area? Okay? So, if I was going to draw the region where y was greater than or equal to this line, that would be over here, okay? So we're over here, and the region where y is greater than this line would be over here, okay? So they intersect in this one. They're not over here. So your answer is C. Okay? In this one, A, this region where you're saying your solutions are, it's not. This is less than this line, okay? We need our solution to be greater than or equal to 2x plus 7. So we need to be on this side of this line, not on this side. Okay? That's why that one's wrong. A few more questions. Number 29. Again, this is recognizing, now in this case you can't get any information from whether you've got dashed or solid, okay? You're straight, less than or greater than. What you need to do is kind of recognize the lines you have. This one is a pretty easy line to see. It's just where y equals 4. So this region is where y is less than 4. Okay, that's going to be one of my inequalities defining my region. And then this line just looks like y equals x. Okay, this is where y is less than x. This is where y is greater than x. Okay, so we're on the side where y is less than x. So this region is defined by y being both less than 4 and less than x. Okay, y is less than 4, y is less than x. That's D. Now these last questions have to do with exponentials and exponential functions, and we have a chart in our room that gives you the laws for operations with exponents. Okay, you can work this out if you need to, or you can reference that chart. Okay, so one rule is that when you have a term that has a power and all of that is to another power, you get this simplification. This is positive 5. You multiply the exponents together. So negative 2 times 5 is negative 10. Okay? And then another law is that a value to a negative exponent is the same as writing 1 divided by that value to the positive exponent. Okay? So this is application of two laws, really. All right? It is the power law, where you multiply the exponents when you've got the situation. And it's the negative exponent law, where this can be written as a fraction. Identify the type of function represented by this expression. F of x equals 4 times 3 to the x. Well, you really just need to see that there's an exponent here, so that's an exponential function. And because this term is greater than 1, it's increasing. So if you have an exponent and the term that's being taken to the power is bigger than 1, you have exponential growth. if this term was less than 1, if it was between 0 and 1, you would have exponential decay. So it's bigger than 1, it's exponential growth. Okay, we've done this before. You've got a function, f of x equals 2 times 3 to the x. It's saying find f of negative 2. Let's just plug in negative 2 for x. We get 2 times 3 to the negative 2 power. You could just put that in your calculator and see which one of these matches, or if you know your exponent laws, you would know that that was 2 times 1 over 3 squared, which is 2 times 1/9, which is 2 over 9. Which of these statements is true for f of x equals 4 times 2 to the x? Okay, it's not decreasing, okay, because we have this number bigger than 1. Or you could even test it. You could put in x equals 0 and see if it gets bigger when you make x equals 1. Okay, you would see that it does. So it's not decreasing. Is the domain greater than 0? Well, not necessarily. You could put negative numbers in for the exponents. So no, you can have, the domain isn't just numbers bigger than 0. You can put in 0. Okay, so B isn't true. What's the y-intercept? The y-intercept is where x equals 0. So this is the y-intercept. 2 to the 0th power is 1, so it's 4. So your y-intercept, where x equals 0, is 0, 4. That's your correct answer. And finally, on a piece of paper, graph this function. Then determine which answer most closely matches the graph. Okay, if you graph this, you can know a couple things. 1, it's a decreasing function. This number is less than 1. 2, my y-intercept is going to be where x equals 0, which is going to be 3 times 0.5 to the 0th power, which is 3 times 1, which is 3. So my y-intercept is going to be at this point where y equals 3 and x equals 0. So there's only one graph of these choices that's decreasing and has an intercept at this point, and that's B. Okay, so that's a walkthrough of this practice exam. Our final exam is going to be very similar to the practice exam. If you can study hard, watch this video on the ones that you don't know how to do, learn how to do them, you're going to do really well in the final.